In episode 12 of the Junior PenTester training series, we are going to go through the introduction to server-side request forgery. And server-side request forgery, as the name implies, is when we submit forgery requests to the server, and if the server has not been configured properly, it will ideally return whatever information we are looking for or do what we want it to do. Typically, everything that we've done up until this point has been client-side requests, meaning the stuff that you do through your own web browser, and then those requests can be manipulated, and your web browser would be your client, right? And then it's sitting on your host, which would be your computer. But from here on, what we're trying to do is we're trying to manipulate the server itself, because technically you can submit something through the client and the client could actually accept it, but then when it gets to the server will actually go through it and it'll say, no, you know what, I'm not going to process this stuff because I've been configured properly, and so the server won't process that request for you. When we do SSRF, the server has not been configured properly, or at least we hope that it hasn't, and what we're trying to do is we're trying to manipulate the server to do what we want it to do. That's what SSRF, or server-side request forgery, actually is. Now, the path itself, or the video that we're going through today, obviously we're going to touch on what it actually is. I kind of gave you like a quick little bit of an overview, but we're going to touch on what it actually is. We're going to go through some examples of it. We're going to find a server-side request forgery. We're going to defeat some of those defenses that would be potentially in place on the server so that we can kind of maneuver and work our way around them. And then of course there's a practical exercise because we are officially in pen testing. Therefore, we have to practice all of these theories and concepts that we're going to be learning. This particular room was created by TryHackMe. I'm pretty sure it was created by a person, but we don't have an actual username that's been assigned to this particular room. And it is a subscriber-only room, meaning that it does require that you have some kind of a paid subscription to TryHackMe. I will say that it is very, very worth it. I sing their praises all the time, and it's not something that I get paid for whatsoever. I don't get any benefits to refer you to them. I just think that it's a really good platform, and if you want to learn hacking, you need a place to actually practice all of the hacking techniques and tactics without getting into trouble legally, and a place like TryHackMe would be the perfect place. So if you don't have a membership already, consider getting one. If not, you can just kind of follow along in this video with me, and you can try to do it against your own servers if you have one, or just try to take some really, really good notes so you can wrap your head around it. And then when we go through the practical, I'll try to explain that to you as best as I possibly can. That being said, quick word from our sponsor, Hackaholics Anonymous, and then we're going to jump into the video. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the introduction to server-side request forgery. In this video, we're going to learn what SSRF actually is, what kind of impact it can have, and some example attacks that we can discover, and what vulnerabilities we can discover, and how to circumvent the input rules. Then we may have a practice for us so that we can go ahead and get some good experience with all of these different newfound skills that we have with manipulating servers. So it should be exciting. So what it stands for is the server-side request forgery, as I've mentioned a few times. It's a vulnerability that allows a malicious user, being you and me, to cause the web server to make an additional or edited HTTP request to the resource of the attacker's choosing. And there are 2 types of this vulnerability. The first one is just a regular SSRF where the data is returned to our screen. The second is a blind SSRF where the actual thing occurs, where the vulnerability itself occurs, but no information is returned to our screen. So if it's successful, you don't really get a success message, or you don't get any information displayed on your screen. So you kind of have to find other ways to verify whether or not your attack was successful. So what is the impact with this? If we can actually successfully launch these attacks, you can get access to unauthorized areas, you can get access to customer or organizational data, the ability to scale to internal networks, and reveal authentication tokens and credentials. Just a few of the very high impact goals that you can accomplish if you are successful with an SSRF attack. So what does it stand for? It stands for the server-side request forgery. As opposed to a regular SSRF, what's the other type? That would be the blind SSRF, where we actually don't see success messages or anything like that. And that is it, what we have for the intro. So let's look at a couple of examples real quick. To go through the examples, we need to click this View Site button that's available over here. These are some of the key benefits that are available through a place like TryHackMe. So when you click that, it opens up in split screen, and then we get to look at this right here. So it says we're going to take you through some attacks and explain how they work. At the end of this, you'll have to figure out one for ourselves. So here we go. The first one shows us the attacker that has complete control over the page requested by the web server. The expected request is what the website.thm server is expecting to receive, with the section in red being the URL that the website will fetch for the information. The attacker can modify the area in red to a URL of their own choice. So this is what we have, right? So the website THM server is going to pull something, right? And it, I guess, is like a stock image or something like this. And so stock, and then everything after the question mark would end up being the parameter that we're requesting, right? So the URL would in this case be the parameter, and it would have a value. And this area in red is the stuff that, let's say, the legitimate returned item would come from the API of website.thm server, and then it would pull stock item ID number 123 is what it would pull for you. But this is also the thing that we can potentially manipulate, right? Everything after this initial parameter, because if you pay attention, there's also another question mark right here that gives a second parameter, which is the ID number equaling 123. But what we're doing is we're pulling this ID from the API of the website.thm servers, and then we are feeding it into the original domain that made that request, right? That's kind of what the expected request is supposed to look like. So the hacker in this particular case would request this, right? The website will then submit that request, and then the API server returns the data to the website instead of any kind of stock information, and then the website returns that data to the actual hacker. So it first goes from the website, then it gets sent to the API, and then the API server will actually submit that, send it back to the website, and then the website would display to the hacker ideally. So that's the first part of this. The next part is how the attacker can actually reach the API user page with only having control over the path by utilizing directory traversal, which is what we talked about a few videos ago when we were going through, I want to say it was EDOR, was the vulnerabilities that we were looking at. Let's see if it was actually EDOR. Authentication bypass. Yeah, I think it was EDOR. It was actually file inclusion. So it's actually the video right before this one was the one that we went through where we looked at a lot of those traversal attacks that we did. So we can do that in this attack as well. So we can combine two tactics technically. So when website.thm receives the ... is essentially going up one level inside of the file system. This is a message to move up a directory which removes the stock portion of the request and returns the final request into the API user portion. So this is what we see right here, right? So we have stock, right? And then the URL would end up being this. So actually it's easier to see it this way. So stock is where we're currently sitting, is where we're at. And then within stock, we're going to request one of the stock images in a normal situation. But what has happened is we've replaced that with the ... So it would take us out of stock. It'll take us back into the root right here. And then usually when you're inside of the root of a file system, there should be a user folder that would be available. So we would do ... go up from the stock location to the root, and then from there we would do /user to ideally end up in the user folder, the user location inside of this specific web server. in that example, or in this particular example, the attacker can control the server subdomain to which the user is made. Take note of the payload ending in the ampersand x equals being used to stop the remaining path from being appended to the end of the attacker's URL, and instead turns it into a parameter, which is the question mark x equals on the query string. So this is what we have right here, right? So we have this is the one that we're looking for in the malicious request, which it goes right here, right after the user, right? It would be ampersand x equals, and then and ID equals 123. So that would be submitted as a request. The website will then submit that request to the actual server. So it would be API website THM, etc. And then it would actually say question mark x equals, which is what the replacement of the ampersand x equals portion would be. And all of that feeds into, it's the subdomain basically. It's like the piece that comes right before the website.thm, because if you see it right here, it's website.thm stock server is what we see, but then that portion was fed before the website.thm, and then API stock item, and then ID 123. So this is converted into this, and the key element for that is this portion right here, the ampersand x equals, because the ampersand x equals, everything prior to that, API website da 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 da, is being placed right before the website.thm in the submitted request to the server. And then we have website.thm da da da, and then we have the and ID equals this. So hopefully it's not too confusing to understand. Feel free to pause the video at this point to just kind of look at the difference between these two elements. This is what is actually submitted to the server. The server will then convert this, right? So, or I should say it like this. This is what's submitted to the website. The website converts this into this and then submits it to the API server. Then the API server will actually return that data to the website, and the website will display it to the hacker. So we made this request to the website. The website converted this request to this request, and it did so based on these few elements, right? When you add this to the end of an image, what it does is that it stops the remaining path from being appended to the end of the attacker and instead turns it into a parameter on the query string itself. And then it was placed at the beginning of the URL, which ends up acting as a subdomain. And then from there, it's submitted to the server. So now if we go back to the original request, the attacker can instead force the web server to request a server of the attacker's choice, right? So instead of requesting the normal server that it would actually request, we can give it a different URL to go and request. And so from there, we can capture the request headers that are sent to the attacker's specified domain. These headers could contain authentication credentials or API keys that are sent by the website.thm that would normally authenticate to api.website.thm. So website.thm/stock, all of this portion is normal, and everything after URL could be replaced with our own URL, what we want to be requested. So the request to the website would end up being this. Instead of it being API website, it would just be hacker domain, right? We could technically give it any domain because it's requesting a domain name. HTTP right here implies that this piece is another domain name that is being requested by the website. So we could just replace that with our own malicious domain. The website request itself will end up not working because that's not what is actually being submitted. We're submitting our own URL, right? So it would just go to our server. Instead of going to the API website server, it would go to our server, and then it would pull whatever the data is from hacker domain THM instead of pulling it from the API of the website. So it no longer actually will even connect to the API website server, the normal standard server, like the healthy server. It will go to our malicious server and pull whatever data may be sitting on that specific domain and then process it for us. That's kind of where the vulnerability lies. So using what we've learned so far, what we're just going to try to do is replace essentially this last portion right here, right? Because this is where the query, the parameter of the query technically starts. So we can change this last portion to read this portion. And I'm going to try to copy and paste this just to save us a little bit of time. And if it works, then what it will do is it'll pull that flag, the flag ID number 9 for us. Okay, there you go. The paste worked. All I did was I just replaced anything that came after the equal sign for the server. I replaced it with this domain that we have here. If we press enter, it says 404 ID not found. Okay, so let's see, maybe there's something else that I need to do. Okay, so the only changes that I really made in order to make this work is I first removed the HTTPS portion of this, and then I added those 3 characters, the ampersand x equals at the end of the query that we can see right here. So the server website, all of that, all of this pretty much stayed the same. The only thing was removed was this piece right here, and then I did the ampersand x9, or the ampersand x equals. I'm curious if it'll work if I still did the HTTPS. No, that part won't work. So we definitely have to do that part. And I'm curious if it will work if we don't do this at the end and it still doesn't work. So it's definitely a requirement to do both of those things. So you have to remove the HTTPS from the beginning, and then you do the ampersand x equals at the end. The rest of it stays exactly the same. So you just put server.website, etc. Put that, and then we will be able to get the flag it's here, which is the SSRF master, which we're definitely not. I am definitely not an SSRF master, but you know, they're stroking our ego for us just to make us feel a little bit better about our exercise. So that is the answer to the question, what's the flag from SSRF? That is the answer. So now we can move on to the various ways that we can find an SSRF vulnerability potentially. These types of vulnerabilities can be found in web applications in a lot of different ways, and these are the 4 common places that we can potentially look. So when you see a full URL that's used in a parameter in the address bar, that could be an indicator. So we just went through that exercise, right? Server equals the server website store, this piece right here. Everything after the server equals, and you see a URL that's inside of it, that's an indicator that you could potentially replace that with your own. Now, in this case, notice that this is an HTTP and it's not HTTPS. That part is very important because when we tried the HTTPS in the previous exercise, it didn't work. Now, I don't know if it's like that was a very, very controlled exercise that they were looking exactly for the value that we put in the URL. Maybe it does work in real life. I haven't tried server-side request forgery exercises too many times. I think this is actually one of my weakest areas, and it would be something that I would definitely be more interested in exploring and learning and practicing. So this is personally very interesting to me, and I would love to learn more about it myself. But what we saw, just assuming that it is a requirement for it to either be HTTP or to just remove this intro part because HTTPS may not work. That's kind of my current conclusion right now. Another one would be that there's a hidden field in a form. So if you look at the HTML or XML source code of a page, this is what it looks like, right? So this is what a form looks like that can be input. You can see that it's a post request that's being sent to the website, meaning we're sending data to the website, and the data that we're sending is the values that go inside of these fields right here. So your name is being printed onto the screen, and then there's an input field for name, and then we would put our name, and it would be stored inside of the client name variable. And then your email will give us an input field right here where there is a client email variable that will store our email address. And then if we want to send a message, this looks like it's like a ticket form that is being submitted to a website. So this is essentially, these are all of the things that we would see. Now, what we don't see is this piece right here. There's a hidden field where it says the server name or the server value itself has this that's being submitted with the form. Anytime that this form is submitted, it's being submitted to the server website store portion of this website, and all of this data is being submitted to this specific server inside of this form, right? So if you see a hidden field, that implies that you could potentially take advantage of that vulnerability. If there's a partial URL, like the host name itself, so we have website HTML, form equals server API. That could be just the host name that is being sent, but it's a partial URL technically, because you see the URL itself, and then there's a server equals API. This just implies that we're submitting, I should have just left it. This implies that we are submitting a request to get access to the API of this server here. And perhaps only the path of the URL itself. So you can see form DST typically is destination, is where it's going. And then now it's going to the path, which is /forms folder. Inside of that, it's going to the contact. And so this is something that would also be housed on the web server. So these are all requests that are being sent to a server. It's just in different ways. This one is literally the link to these servers inside of the URL. This one is inside of a form on the page, and you can see that there's a hidden portion. So this element right here isn't going to be displayed on the screen when you're looking at it in regular view, not looking at source code, right? So when you see this right here, it's like, oh, okay, so that's probably what's going on. They're making a request to this server right here. This is another version of this. It's just a shortened or a partial URL, and we can see that it's being sent to the API server. And then there's the path of the URL that we can see is being fed into the destination variable, the destination parameter, and the argument is the /forms and contact. So these are easier to exploit. Some of them, I should say, are easier to exploit than other. And this is where a lot of the trial and error will be required to find a working payload. If working with blind SSRF, where no output is reflected, you will need to use an external HTTP logging tool to monitor requests like requestbin.com, your own HTTP server, or Burp Suite's collaborated client, which is very, very handy. Burp Suite is another one of these tools that you're going to end up seeing used very frequently, especially as we go through more and more pen testing exercises. There are many videos on this channel already that talk about Burp Suite, so this is all just very, very interesting stuff. Based on the simple observation, which of the following URLs is most likely to be vulnerable to SSRF? So this is basically the only question that we have right here. So out of these right here, which one do you think is the most vulnerable? So this one is a website, and it's just going to the index.php page, which is typically just the home page of a site. Anything that you can see with index HTML, index PHP, this typically implies that you're just going to land on the home page of the site. Website.thm, list products.php, and then you're asking for the category ID of 5325. Most likely not, because it doesn't seem like it's asking for anything from a specific server location. This one, HTTPS website, fetch file.php, and then there's a file name that's being sent as a PDF, and the server is filestorage.cloud.thm, and port is 8001. So this is actually making a request from a server right here. We're going to filestorage.cloud.thm on port 8001, and we're trying to pull this specific file name from that location. And then we have website.thm, buy an item, item ID, price, etc. So this doesn't seem like one. This doesn't seem like one, and this doesn't seem like one. The one that actually looks like it's submitting a request to a server is option number 3, which is the correct answer. All right. Defeating the common SSRF defenses. More security-savvy developers aware of the risk of these vulnerabilities may implement checks in their applications to make sure that the requested resource meets specific rules. So this is where the configuration of the actual server itself will come in handy as far as defensive tactics are concerned, right? So if you're trying to take advantage of a server, if the security developer or the developer, right, was actually security savvy, they'll put in some checks, right? They'll put in some protocols in place to make sure you can't do request forgery. There are usually 2 approaches to this, either a deny list or an allow list, basically denying a certain list of requests or only allowing a certain list of requests. And that's basically what it is, right? It's like a deny list is where all the requests that are accepted apart from the resources that are specified in this list or matching a specific pattern. So you can allow anything except the stuff that's on this deny list. The web application may employ a deny list to protect sensitive endpoints, IP addresses, domains from being accessed by public while still allowing access to other locations. A specific endpoint to restrict access to is the local host, which may contain server performance data or further sensitive information. So domain names like localhost and 127.0.0.1, which is the standard IP address that belongs to the local host on every single computer. There has not been a single computer that I have done ifconfig or ipconfig on where the loopback address or the local host address was not 127.0.0.1. That's basically the IP address for the loopback or the local host. And it would appear on a deny list, right? So these things, the local host name and this specific IP address would be on the deny list so that if we wanted to access them, we shouldn't be able to access them. Now we can bypass a deny list by using alternative local host references, for example, 0 by itself, or 0.0.0.0, or quad 0, or 127.1, or 127.*****. There's also this piece right here, which I think is just kind of one of those general addresses that I've never seen before, so I haven't memorized this one. This is another one. Or any kind of subdomain that has a DNS record which resolves to the IP address of the local host, such as 001 nip.io, right? So in a cloud environment, it would be beneficial to block addresses to the IP address, this specific IP, which contains metadata for deployed cloud server, including possibly sensitive information. An attacker can bypass this by registering a subdomain on their own domain with a DNS record that points to that specific IP address. So these are very, very interesting ways that we can bypass these things, right? So unless the actual developer has blacklisted this, all of these, right? Or these IP addresses like this specific piece right here, unless all of those have been blacklisted, you could technically use those to bypass that initial portion of the deny list that wouldn't give you access to localhost and 127.0.0.1. And in a cloud environment, if we have this specific IP, which we can actually even Google this, right? So let's go and let's see. I don't want to do that. So let's look this up. I wonder if it's going to look it up in my computer or if it'll look it up online. Nope, it's not looking it up online. It's going to probably do a lookup on my actual computer, which is not what I'm trying to do here. I'm trying to see what it would look like if we searched for this. So if we go ahead and type it into the browser, it should just be blocked because it's now trying to go into that address. So we're definitely not going to get that request completed. If I put it in inside of Google and try to do a Google search, so let's stop this altogether. Let's actually go to google.com and then submit it as a request to google.com and see what happens. So it says, what is this IP address? And it's used in AWS, Azure, GCP, and other cloud computing to host instance metadata services. So this is actually an IP address that's a default IP address that's used in Amazon, Azure, Google Cloud, and other cloud computing platforms to host the metadata of an instance. So when you have an instance that's being launched in a cloud environment, that's basically launching, let's say, a Linux machine or launching a Windows machine. It hosts the metadata of those various instances, which are all connected to potential virtual machines or Dockers or anything like this that's being released. So in the context of AWS, for example, this IP is used as the endpoint for the instance metadata service, and the EC2 metadata service provides a way for EC2 instances to retrieve instance-specific information and configuration details. So if we can access that for a given website, then what will happen is that we will get configuration details for that virtual machine or for that instance, right? So it's very interesting to actually know about these default values. And there's all of these default values, and then there's just this IP address that, if you had not gone through this video, you probably would not have guessed that there's something like this that exists, right? So one of the things that are available through videos like this one are that you can find what to search for. A lot of times, you know that you have a certain goal, but you don't know where to start the search. And so in this particular case, if your goal is to find information about cloud environment instances, this is where the search would start, would be at this specific IP address, because it literally applies to Google Cloud, Amazon, Microsoft Azure, all that stuff. So all of that was the deny list, right? The allow list is where all the requests get denied, so everything gets denied unless they are actually on the allow list or they match a particular pattern, like a rule that a URL used in a parameter must begin with https website.thm. If it doesn't start with this, then it's not allowed, right? It's everything else is denied. So an attacker could quickly circumvent this by creating a subdomain on an attacker's subdomain name, so on their own domain name, such as website.thm.attackersdomain.thm, right? So if it starts with this, if that's the rule, and we figured out that that's one of the rules that we have because we looked at the configuration for the instance, you see what I'm saying? So once you figure out the configuration rules, you're like, oh, you know what? As long as I have something that's registered on my own computer, or excuse me, on my own website that has this as a subdomain, it's the website.thm, and then there's the .attackersdomain. So as long as it starts with this, then I should be able to get access. And technically you should, right? The application logic will now allow you, or allow that specific input, and let you control the internal HTTP request. There's something known as an open redirect. So if the above bypasses, the stuff that we just talked about, don't work, there's another trick that we can do. And the open redirect is an endpoint on the server where the website visitor gets automatically redirected to another website address. So for example, if we go to this, right, this piece right here, this endpoint was created to record the number of times visitors have clicked on this link for advertising marketing purposes. But imagine there was a potential vulnerability with stringent rules which only allowed URLs beginning with this, right? Then you could utilize the above feature to redirect the internal HTTP request to a domain of the attacker's choice, which is basically what we just talked about in the previous one. So if this is the rule right here, so it says anything that is done through this will go to this specific endpoint to record the number of times that visitors have actually clicked on this. And the potential vulnerability is because of the rule that says that only the allowed URLs that begin with this portion are allowed to be submitted. So again, we can go ahead and just add that as one of our subdomains, and then we'll be able to pull off the rest of it. So as long as this is included in our subdomain, everything after that could technically be our own stuff, and we should be able to get past it because this was just one of the rules that were submitted to the configuration of the server as an open redirect, because they just want to track how many times a click is being sent to this specific URL, for example. So what method can be used to bypass strict rules? That would be the open redirect. What IP address may contain sensitive data in cloud environments? That was the 169 address that we found. What type of list is used to permit only certain input? So that would be the allow list, which forces you to deny everything else. And what type is used to stop certain input? And that would be the deny list, which then allows everything else, right? So those are the types of request forgery mitigation tactics that we can actually go through defeating the various SSRF defenses. So all of that being said, let's actually do a practical exercise here. Okay, so here is the scenario. We have two endpoints during a content discovery exercise against the Acme IT support website. The first one is /private, which gives us an error message explaining that the contents cannot be viewed from our IP. The second is a new version of the customer account page at customers new account page with a new feature allowing customers to choose an avatar for their account. By clicking start machine, I've already done that. It'll launch that, and then we'll be able to get access to this. The IP address portion of this changes every time you do start machine. I've also launched the attack box so that we can use the internal connection between the attack box and this IP to actually open it in our browser. If you don't want to use the attack box, you can always connect to the TryHackMe server via OpenVPN and then just use your own computer, and then you'll be able to load this. If you do this outside of that, outside of your own, or outside of the attack box without connecting to the TryHackMe server via OpenVPN, it won't load. So this is what Oh, actually loaded. Oh my God. So maybe I guess it's because I'm already connected via attack box. Maybe that's why it's working. That's so odd. I didn't think that it would even load. Oh my gosh, that's crazy. All right. So then follow the instructions. I'm legit shocked. Like I'm shook right now that this actually loaded. That's so funny. Maybe I didn't even need to open the attack box. Maybe it would just work without the attack box. I guess, whatever. First, create a customer account and sign in. Once you've signed in, visit this specific location to view the new avatar selection feature. By viewing the page source of the avatar form, you'll see the avatar form field value contains the path to the image, and the background image style can confirm this in the div element. So if we actually go look at the source code, we'll see under the class for avatar image that there's background image, and then there's a URL assets avatar 1 PNG. So if you choose the avatar and then click update avatar, you'll see the form change, and above it displays your current avatar. So for example, if we change it, it should change it to something else, right? Background image, URL data image, PNG, base64, etc. So viewing the source will show us that it's actually being displayed using the data scheme, and it's and it's base64 encoded, which is what we see right here. So let's try making the request again by changing the avatar value to private in hopes that the server will access the resource and get past the IP to block. To do this, firstly, right-click on one of the radio buttons from the avatar and then click inspect. So if we just look at the actual button itself and inspect it, then edit the value of the radio button to private. So this piece, the radio, just change the value to private. Be sure to select the avatar you edited and then click the update avatar button. Unfortunately, it looks like the web application has a deny list in place and has blocked access to the private endpoint. Okay, so as we can see from the error message, the path cannot start with private, but don't worry, we've still got a trick up our sleeve. So we can use a directory traversal trick to reach it. Try setting the avatar value to x/../private. So this is the traversal portion that comes in. Now we'll see that have bypassed the rule, and the rule updated the avatar. This trick works because receiving the request for this, it knows that this piece means to move up a directory and translate it. So as long as it doesn't start with /private, I think that's the rule that was in place. If it starts with /private, it won't work. But technically now it starts with X, and then we've done a directory traversal, and now we're going to private, which will, this is pretty much the equivalent of just saying that we want to start with private, but the query itself doesn't start with private, and so that bypasses the rule. Viewing this, you'll see the currently set avatar now contains the contents from the private directory in base64 encoding, and then you can decode it to find the red flag. So first things first, I want to actually use the attack box that we have anyway, so I'm just going to do show split view, which is going to be really insane. So I'm going to click this view full screen just so it opens it up in full screen for me, and I'll be able to look at the actual screen. Then we are going to open up the browser, and then we're going to navigate to that IP address that they gave us, or that path, which is this whole piece right here. So we're just going to copy this, and we're going to go in our browser, and we're going to paste it, press enter, and we're going to go to customers first and sign up, and then we're going to create a customer profile. So it'll just be Hank, and then is it going to type? There we go. Hank@thm.com. None of this needs to be real because, I mean, it doesn't, which is odd to think about, but it'll create it for you no matter what, and you'll be fine. So now we're here. So, okay, so we're here. So what it's telling us to do is to go to the portion for customers' new account page to view the avatar selection feature. Okay, that's where we need to go. So customers is where we're here, and I think it might work if I went to your account. I think that might take me there. If it doesn't, then we can just manually go there. Yeah, so this just takes me to my actual account itself, but there is the new account page. So new, what is it? New dash account dash page. All right, so here are the avatars. So now it's saying, if I click this guy right here, so let's zoom in a little bit for you just so you can see what's up. If I click this guy right here and I right click on the actual button, right, and I inspect the button, we can see that there is this value right here, right? So the value is assets, avatar, PNG. So just to display what they did, right? If we just go to /private, press enter, and then do what, a refresh, I guess? It should say, no, it doesn't do it. So what does it say? So it says if we go over here and we do click update avatar, you'll see the form change, and above it we'll have that. And then this is what's going to happen. So if I go to that and then do update avatar, so that's what I got to do, is I got to go here, I got to right click on this guy, go to inspect, it'll bring it up over here, and then I'm going to change this value to /private, and then I'm going to click update avatar. That's what's going to say. So URL cannot start with private. So there it is. So now we know we can not do that. So what we can do again, we'll click on this guy, and then we will go ahead again and do right click, inspect, and it'll take us to that specific one. And we'll have here, we're going to do x / private, and press enter here. Then we're going to click update. And so now it says avatar was updated. Okay, so now we need to just look at the page source and then look for the current avatar portion. So it's basically this piece right here. So I'm just going to highlight that, do an inspect, and it'll take me here. And so now we have the current avatar background image, URL data, base64, and then there's this base64 encoded portion right here that I should be able to, I'm just going to do this. I'm going to copy this whole thing, and we're just going to go to CyberChef and modify it inside of CyberChef. So we're going to do this. I think it's going to paste that whole piece. And what I'm interested in is removing all of this, right? And then removing that last parentheses at the end as well, like so. And then we'll just click on this magic wand, and there you go. THM, you worked out the SSRF. So fairly simple exercise, okay? Just to kind of, because they gave us pretty much everything that we needed to do. So just so you can see what's up, right? So essentially, if I click on this one right here, and then I go update avatar, it'll change it. Now here's my current avatar. And now we can see that the current avatar actually has a picture here, right? So this is me without doing any kind of modification to the source code. This is what it would actually display. So if we right click on this, click on inspect, it'll take us to that portion, and we can see that it's, you know, image, base64, etc. So I can literally just take this, very similar to what we had previously, and you see like this giant portion of text right here. And we can copy this, go over here, and go to the CyberChef and paste it. And then if we remove that first portion of this, which is the base64 element, all of that, remove that first, come to the very, very end of it, and remove this parentheses, it should give me something, but it gives me absolutely nothing. So it tells me that pretty much this, most of this is jargon or it's garbage. So if I look for the double equal sign on this page, let's see if I can do that. So if we do Control F, do a double equal sign, and then see if we can find it, there is no double equal sign. So it seems to be that it doesn't even exist in this particular case. So if I do a single equal sign maybe, so let's see if we can find a single equal sign in all of this, and it doesn't exist in all of this. So this whole thing implies to me that this, all of this right here, is just like a really complicated placeholder to let us know that this is just BS, right? So then it's kind of irrelevant at this point. The key element was if we click on this guy, right click on the actual button, go to inspect, we'll see that the value of it, and based on the types of request forgery, we saw that the value right here was assets avatar 3 PNG, which is a path that we can see right here. So we can actually change this, right? So we're doing a combination of two exercises here. We're going to do the changing for SSRF, but we're also combining it with the path traversal, which is where that x / ... and then we're going to go to private. Now this piece right here is the piece that, like, they've done the homework for us. They know that there's a private page, and all of those things. And so all we need to do is just try to find a way to access that private page. And this is, now we can see that the current avatar is actually blank. But if I right click it, or if I just go here and I right click this and I do inspect, it'll take me to that portion. And now I can see that the avatar image has now been modified to whatever that private page's base64 was, which is much shorter than that giant thing that we saw at this piece right here. So then when we pasted that, we saw that the value itself was the flag. So I kind of like jumped the gun and I got to the answer at the end of it. But hopefully now you understand how the thought process behind this works. And to find those private pages, you would just do one of the scans that we normally would do when we go through reconnaissance, and you can use Nikto for that, you can use GoBuster for that. There are a lot of different ways that you can find these various directories that would be available. For example, the directory that we have here, which is the new account page, as well as the directory for /private. So both of those could just be found by doing a GoBuster scan. And then from there you find them, and then you document all of them, and then you go ahead and you analyze the web page for potential vulnerabilities that may exist, and that ends up making it kind of fun to then just now try to break into the system, which is what we were able to do quite successfully, if I may say so myself. So there's your answer. The THM, you worked out the SSRF, and we are officially done with this room. This is actually a great introduction to server-side request forgery. If you've never done anything like this before, hopefully this was easy enough to wrap your head around, and hopefully you got a chance to actually practice it because you were inside of TryHackMe. Now, if you weren't, I totally understand. You can try to follow along. I try to over-explain. One of our guys, one of our members of Hackaholics Anonymous, he's like, look, over-explaining is actually not a bad thing, and it helps people understand these things better. So I hope that when I go into these deep explanations, it actually helps you and doesn't hinder you. And if you're really sharp, if you're one of those viewers that is really, really good at retaining information and you're very good at understanding these things, then you can skip past most of that stuff. But I do it for people that are not from cybersecurity. They don't have a background in tech or a background in web development or anything like that. So just to make it a little bit easier for them to understand what's going on. And especially if you don't have access to TryHackMe as a paid member, then I kind of have to over-explain just so you understand what just happened, what we went through, and what we did. Because just to go through the exercises willy-nilly and try to get you the answer to the final question, it is more useful for the people that actually have access to TryHackMe and they're trying to complete the room. But if you're just trying to learn what it means to do server-side request forgery, I feel like I do need to over-explain. But anyways, in any case, we got a chance to understand what it actually means to do a server-side request forgery. We looked at the various ways that we can find those types of request vulnerabilities, and we even were able to launch it against an actual website to see what we can do and manipulate. And of course, the defenses that would be in place, we kind of found out how to get around them, which is what this very last exercise was. So hopefully it was actually valuable to you. Hopefully you learned something from it. And yeah, that's pretty much it. If you did get value out of this video and you want to get more videos like this one, I encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out. And I've gotten some comments from people that they're like, I don't get notified when new videos come out. That's because you didn't turn on that notification bell. I think it's like, it would be like right down here. It's like right under the video. And if you turn it on, then you will actually get notified the next time that a video comes out. But then just keep in mind, I post videos pretty much once a day throughout the work week. So Monday through Friday, there's always going to be at least one video that's going to get posted. So if you don't check your YouTube frequently, you're going to get a bunch of stuff. After like 2 weeks, you'll probably get 10 videos that are updated. So just keep that portion of it in mind, but you can always just make sure you subscribe to the channel, and then the new videos will pop up in your feed. So there are a few different ways that you can be notified of this. And then there are some people that also just drop comments inside the comment sections of the timestamp that they were at, so that when they come back, they can just pick up from where they left off, because a lot of the longer videos, some of the videos on here are like 4, 5, 6 hours long. So a lot of those videos, important to just pick up where you left off so you don't have to click back and forth. I put timestamps in every single one of the videos to make it easier for you to navigate the video and find a specific part that's most interesting to you or applies to you, or you can go to that part and then pick up from where you left off. So hopefully it makes it a little bit user friendly and you can get access to the information that you need. There's a bunch of videos already on the channel. There are going to be more videos coming out. The current big playlist that I'm working on, there are two big ones. This Junior PenTester is one, and then we have the CompTIA Pentest Plus that drops every Friday. There's a new episode that drops every Friday, and hopefully within, let's say, a month or so, I'll be done completely with that, because I'm going to do like a big bulk recording of everything for that, so we can get all of that done for you. And then the most important piece that's going to be coming up is just the integration between AI and all of these various tools. And I have to do all of these foundational pieces so that you understand what's going on, so that when we go into the advanced stuff like AI integrations with cybersecurity tools, those things you can actually really wrap your head around. Because if you don't know the basics, those things are going to be impossible to understand, and I'm going to get a bunch of comments from people asking me to explain the basics to them. So I have to do the basics to make sure that you have access to the basics, and hopefully you'll actually go through them and learn them so that everything else will start making sense for you as well. So drop a comment if you have any questions about the video that we did today. If not, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. And a quick word from our sponsor and we'll be done. If you're serious about your CySec education and you want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the comment section, and if not, I hope I see you in the Discord chats. And that's it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video later.